Hello everybody. Today we are going to do section 33.1, which is the Pythagorean identity. Okay, just a few things that we need to talk about before we go into solving these trig functions down below. First of all, remember those special right triangles that we went over in the last section? It should make sense that this would be your x and this would be your y. We're going along the x-axis here and then along the y-axis there. The x value is going to be represented by cosine, and the y value is going to be represented by sine. This will also make even more sense when we go on into the unit circle next. All right, then a couple things or other things I want to talk about is here we start at 0. And if we think about a circle is 360 degrees, right? We already discussed how to switch from degrees to radians and radians to degrees. So at 90 degrees in radians, that is pi over 2. At 180 degrees, that is pi in radians. And then at 270 degrees, we are at 3 pi over 2 in radians. Okay, and then remember a full circle is 360 degrees, which is equivalent to 2 pi in radians. Okay, so I'm going to refer back to that in a little bit. Also, something I want to point out over here, remember your quadrant numbers. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. There's a little trick here. It's called all scholars take calculus. Okay, the A stands for all, S stands, whoops, I already put this. S stands for sine, T stands for tangent, and C stands for cosine, okay? This is where the trig functions are positive. So for an example, in quadrant 1, so over here, sine, tangent, and cosine are all positive. In quadrant 2, over here, only sine is positive. Cosine and tangent are negative here. Okay, and then same idea down here as well. Okay, I'll refer back to that too. Okay, it says express the relationship between the sides of a triangle on the unit circle with the Pythagorean theorem. We know what the Pythagorean theorem is. That's x squared plus y squared equals 1. Okay, the Pythagorean identity looks very similar, except it says sine squared plus cosine squared equals 1. Okay, sine is your y, so that's like the y squared part, and cosine is your x, so that's where the x squared part comes from, equals 1. All right, so you guys can see that this is very similar to the Pythagorean theorem. We're just throwing sine and cosine in to call it the Pythagorean identity. Okay, you could write cosine squared plus sine squared if you want. It's the same thing, that's just the additive property. Up to you though. All right, so let's do some examples. I got 4 for you. All right, number 1 says, given that cosine is -3/5 and that pi over 2, or theta is in between pi over 2 and pi, find the value of sine and tangent of theta. Okay, so first of all, we need to find out what quadrant our answers need to be in, right? So pi over 2 is here and pi is here. So we are in this quadrant, quadrant 2. Okay, so let's go ahead and try to solve for sine and tangent though. So let's see here. Let's do sine squared theta plus, I know what cosine is. Cosine is -3/5. So -3/5 squared equals 1. All right, and we're just going to go ahead and simplify down to sine. All right, so sine squared theta plus 2 negatives multiplied by each other make a positive. 3 squared is 9. 5 squared is 25 equals 1. Okay, now I'm going to subtract the 9/5, or 9/25, sorry. So I get sine squared theta equals, let's see, 1 minus 9 over 25. Keep it as a fraction, 16 over 25. And then to get rid of that square, I'm going to square root both sides, just like I were if that said x squared, right? So I get theta equals, remember you take the square root, you get plus or minus 4/5. fifths. Square root of 16 is 4. Square root of 25 is 5. All right. Now, because our we have a restriction from pi over 2 to pi, our answers have to live in quadrant 2. So we are dealing with sine, right? Oh, whoops, I forgot to say sine theta here. All right. So in quadrant 2, up here, in quadrant 2, sine is positive. So I can ignore this negative 4/5. All right. So my answer is actually just 4/5. And it's because we are in quadrant 2. So I can disregard the negative because in quadrant 2, sine is positive. Does that kind of make sense? So I'm going to write sine of theta equals 4/5. So that's where the quadrant part plays a role. Okay, now tangent. Remember, tangent is sine over cosine. You can think of that as also y over x, right? Same idea. So I have 4/5, that was my sine value, over my cosine value is negative 3/5. Remember, when you are dividing by a fraction, you're really multiplying by the reciprocal, not the opposite reciprocal, just the reciprocal. So those flip, I get negative 4/3. Tangent of theta equals negative 4/3. And let's double check that. So again, if we're in quadrant 2, okay, only sine is positive. So that must mean my cosine and tangent answers must be negative. I have a negative tangent and cosine was negative, so I'm good. Okay, that's kind of a way to go back and check yourself. Alrighty, let's do a couple more. Alright, given that sine theta equals negative 12 over 13, and that theta is in between pi and 3 pi over 2, find the value of cosine and tangent. So let's figure out what quadrant we're in first. Here's pi, here's 3 pi over 2, so we are in quadrant 3. All right, let's go ahead and plug this into the equation. So negative 12 over 13 squared plus cosine squared theta equals 1. So I'm plugging that into the Pythagorean identity. All right, whoops, negative 12 over 13 squared, oops, got to keep those fractions, 144 over 169 plus cosine theta equals 1. I'm not going to show quite as much work here, but I think we understand the idea. I'm going to subtract the 144 over 169 to both sides. So 1 minus 144 over 169. So cosine squared theta equals 25 over 169. And then I gotta take the square root. So cosine of theta is plus or minus 5 over 13. Now, because we're in quadrant 3, remember, all scholars take calculus. Only tangent is positive in quadrant 3. So I have to look at I want the negative answer. I want negative 5 over 13 because we're in quadrant 3, cosine is negative. Okay? All right, so I get cosine of theta equals negative 5 over 13. And then tangent is sine, which was negative 12 over 13, over cosine. Right, yeah, okay, sorry. Negative 12 over 13 times negative 13 over 5. So I get two negatives make a positive, so 12/5, which that makes sense because tangent is the only trig function that's positive in quadrant 3. So tangent of theta equals 12/5. Alrighty, got two more examples. The formula is pretty easy, it's just the simplifying piece of this. Alright, number 3, given that cosine of theta is negative 5 square root of 3 over 10, and that theta is in between pi over 2 and pi, find the value of sine and tangent. So pi over 2 and pi, we are in quadrant 2. Okay, So real quick, before I plug this in, do you guys see that this reduces to negative square root of 3 over 2? Because 5 over 10, I can divide those both by 5, right? So that's a 1, and that becomes a 2 there. Okay, so here we go. Sine squared theta plus negative square root of 3 over 2. Oh man, having a hard time writing that. Sorry. Squared equals 1. Yeah, okay. All right, sine squared theta plus 2 negatives make a positive. That just becomes a 3 over 4 when I reduce that. And then I get sine squared theta equals 1 minus 3/4 is 1/4. Square root it. I get sine of theta is plus or minus 1/2. Okay? Now, because I'm in quadrant 2, all scholars take calculus. Sine is positive in quadrant 2. So I'm going to say sine of theta is 1/2. I want the positive answer, okay, because we're in quadrant 2. All right? 1/2 because of quadrant 2. All right, sorry. Okay, and then tangent. So that's sine over cosine, negative square root of 3 over 2. Okay, this is where some of the simplifying gets a little tricky. We do want you guys to have no decimal answers, so you might need to show your work here to keep that as a fraction. All right, so I'm going to multiply by the reciprocal. These 2's are gone, so I get negative 1 over the square root of 3. And remember, we cannot leave a radical in the denominator. We learned that when we talked about how to simplify radicals. So I'm going to do something called rationalization, if you remember that R, that big R word that we use in math class. Okay, so I'm going to multiply both the numerator and denominator by that denominator there. So I get negative square root of 3, 1 times square root of 3, square root of 3, over square root of 3 times square root of 3 is the square root of 9, which is 3. And remember, you cannot simplify these 3's because this 3 is not under a radical, so you cannot divide those. So tangent of theta is negative square root of 3 over 3. And that should make sense because in quadrant 2, tangent is negative. So we did good. All right, last problem. Let's see. Given that cosine is 7 over 25 and that we are or theta is in between 0 and pi over 2, find the value of sine and tangent. So here's 0, here's pi over 2. We are in quadrant 1 in this problem. Okay? So I get sine squared theta plus 7 over 25 squared equals 1. So sine squared theta plus 49 over, what is 25 squared? 625 equals 1. I'm going to subtract the 49 over 625. So 1 minus 49 divided by 625. If you guys are having any troubles typing this in your calculator, make sure, make sure you do 1 minus the fraction in parentheses or else your calculator won't read it right. Remember, you're smarter than your calculator. Okay, I want to change that to a fraction. Well, that's a big guy. All right, take the square root of both sides. So I'm just going to hit second square root, second. The little negative sign is answer, and it will take your answer and like copy that in there. That was second, and then the little negative sign in the bottom right where it says ANS for answer. So sine squared theta is plus or minus 24 over 25. Learn something new every day, right? Okay, and because we're in quadrant 1, all scholars take calculus. In quadrant 1, all the trig functions are positive, so all my answers need to be positive. So it's going to be 24 over 25 because we're in quadrant 1. Oh, why did I write a square there? You take the square root of sine, it's just sine. Sorry. Okay, so sine of theta is 24 over 25. Look, cosine was positive, so that's good too. Tangent also needs to be positive. So tangent of theta is 24 over 25 divided by 7 over 25, which is 24 over 25 times 25 over 7, 24 over 7, and that does not reduce. So tangent of theta equals 24 over 7. All right, that's it, guys. Another way you guys can look at this real quick, I'll just do it with example number 4. Let me grab my pencil again. So because we are in quadrant 1, you guys can think of it kind of like this. Remember, cosine in SOHCAHTOA is adjacent over hypotenuse. You guys could like draw that. So because I'm in quadrant 1, my triangle is going to look like this. Okay, here's theta. That's the angle. The adjacent side is 7, and the hypotenuse is 25. So you're almost kind of like, that's where the Pythagorean identity comes in, is you guys are basically doing x squared plus y squared equals c squared, essentially, right? So that's how that's playing a part, but you guys can just skip kind of like to that step and using that formula. Make sure you understand all scholars take calculus. Remember that little saying. All right, that's it, guys.